Good morning everyone. Today we are going to learn about new topic in modern manufacturing robots. Industrial robots. In this topic we have to learn definition of robot and robot configurations and robot anatomy, robot work volume, robot drive system, robot actuator, end effector. These topics we have to learn. Let us first we know what is industrial robot. An industrial robot is a programmable multifunctional machine designed to perform a variety of tasks in manufacturing and production environment with very high speed, accuracy and repeatability. That is, the robot is the programmable. We can program n type of works. There's a multifunctional machines. The robot function in the different types of works in modern manufacturing industries. The robot, there's a robot definition according to the Robotics Industries Association. An industrial robot is a reprogrammable multifunctional manipulator designed to move material, parts, tools or specialized devices through variable programmed motion for the performance of different tasks. Then next, characteristics of robot. Characteristics of robot. First, initially programmable device. Thus, industrial robots can be programmed to perform different tasks as required. Their operation can be easily modified by changing the program. The automatic operation. Robots can perform tasks automatically without continuous human control. Once programmed, they work independently in the production process. Next one, high precision and repeatability. Robot can perform tasks with high accuracy and minimal error. They can repeat the same operation multiple times with consistent result. Next is the robot is the flexible. Robot can be adapted to perform a variety of tasks in different applications. They can switch between operations with minimal setup changes. Then high speed. Industrial robot can operate at high speed compared to human workers. This increases productivity and reduces production time. Then robot basic components of industrial robots. What are the components is there? Initially there is a manipulator, drive system, control system, end effector, sensor. Manipulator. The manipulator is the mechanical structure of the robot consisting of links and joints. It enables movement and positioning of the robot in its workplace. Next is the controller. The controller acts as the brain of the robot, executing programmed instruction. It processes input signal and control all the robot movements and operations. The end effector. The end effector is the device attached to the robot's arm to perform specific tasks. It can be gripper, welding tool, spray gun or any specialized device. Next part is the sensor. Sensor detect physical parameters like position, force, temperature or vision. They provide to the controller for accurate and safe operation. Then is the drive system. The drive system provides the power needed to move the robot joints. It uses actuator such as electric motors, hydraulic or pneumatic systems. Now let us see the robot configurations. What are the configurations? Robot having the different configuration, that is the Cartesian coordinate, then cylindrical coordinate robot, spherical and articulated jointed arm configuration, SCARA configuration. First, what is the robot configuration? A robot configuration refers to the geometric arrangement of the links and joints that determine the structure of the robot, its work envelope. The configuration of a robot influences its reachability, accuracy, payload capacity and suitability for a particular application. The commonly used robot configuration are first initially Cartesian configuration. The Cartesian configuration, all the three joints are prismatic given rectangular coordinates. All the joints are moving in straight line motion. The Cartesian coordinate work envelope is box shaped. Then this is simple in construction and easy to program. Then Cartesian coordinate robot used in pick and place, CNC loading, assembly, etc. Then is the cylindrical configuration. In cylindrical configuration, that is the one rotary joint at the base and the two prismatic joints. One is the rotational movement. The work envelope is the cylindrical. Then cylindrical configuration provides larger work area than Cartesian. Used in welding, machine loading, material handling, etc. Spherical configuration. Two rotary joints and one prismatic joint. Work envelope is spherical. Then the spherical configuration more flexible than cylindrical coordinate robots. Spherical coordinate robot used in arc welding, spray painting. Then articulated jointed arm configuration. All the three joints are rotary joints. Here articulated jointed arm configuration. This robot having each and every joints is the rotational movement. Here that work envelope is the irregular, almost spherical. This type of robot is high flexible and can reach difficult position. Most widely used in industry. This type of robot used in spot welding, assembly, die casting, material handling. SCARA configuration robots. SCARA configuration robot, two rotary joints in horizontal plane and one prismatic joint in vertical direction. This type of robot work envelope is the annular. This type of robot is high speed and good accuracy in assembly tasks used in electronic assembly, screw driving, pick and place robots. Next we have to see the robot anatomy. Robot anatomy means there's different parts of the robot. Robot anatomy refers to the main parts of a robot and the function of each part. Although robots come in many designs, most contain these essential components. That is, the first one is the body. The body of the robot is supports and protect all the internal components. The body of the robot made from materials such as aluminum, steel or plastic material. Then controller of the robot, the computer or microcontroller that process information, execute programs and makes decision based on sensor input. Then robot having the sensor allows the robot to detect its environment. That is we have to use different types of sensor. There is a vision sensor, ultrasonic sensor, infrared sensor, touch sensor, temperature sensor. Then is the next part is the actuator. Actuator is convert electrical energy into movement. That is the electric motor, servo motor, hydraulic actuator, pneumatic actuator we have to use in robots. Power supply system. Power supply system provides energy to the robot. Can be rechargeable batteries, power adapter or solar panels are used in robotic system. End effector. End effector, the part that performs the robot task. Finally, the robot having the end effector or hands or tools. The end effector is the one of the important part to perform the robot task. That's the examples. That's a gripper, welding tools, vacuum cups, surgical instruments. Whatever parts we needed, we replace it and function the robots. Communication systems enables communication with the users or other devices. Then next part is the work volume. Work volume or work envelope is the robot. So first of all, work volume is the three-dimensional space within which a robot can move and perform tasks. The work volume depends upon the robot structure, joint type and range of motion. Work volume is the reachable area of the robot's end effector. Different robot configurations have different work volume shapes. Next, importance of the work volume. So, importance of the work volume helps in proper robot selection for tasks. The work volume ensures efficient workspace utilization. Work volume avoids collision and unreachable position. Work volume in robotics that determines where a robot can operate effectively, directly impacting productivity and application suitability. Then each and every robot configuration have different work volumes. In Cartesian coordinate robot, that's a work volume rectangular or box shaped. Suppose cylindrical robot means cylindrical shape, spherical robot means spherical shape, scalar robot annular shape, articulated robot complex shape work volumes that are having. Then is the precision movement of the robot. Next part of the industrial robot is precision of movement. Precision of movement in robotics refers to how accurately and consistently a robot can reach a desired position or follow a specified path. Robot can reach a required point and perform tasks without error. Higher precision ensures better quality, consistency and efficiency in operation like assembly and machining. In precision in movement, robot having different characteristics. First one is the accuracy. Accuracy means it is the ability of the robot to reach the exact desired position. It shows how close the robot heads to the target position. Repeatability, it is the ability of the robot to return to the same position repeatability. Even if slightly off target, it should be reach the same spot every time. Then resolution, it is the smallest movement increment the robot can detect or make. Higher resolution means finer and most precise motion. Factors affecting the precision. The mechanical design and joint quality. So we have to improve the better quality of design means we have to move the robot is very quickly. Then sensor accuracy and feedback systems. That is the control system performance. External forces like load, vibration and temperature, these factors are affecting the robot precision. Then importance of the robot precision, ensure high quality production. Suppose in robot precision is very higher means ensure higher quality production, reduce errors and defects, essential for tasks like assembly, welding and machining. Then important parts of the robot drive system. The robot drive system is the mechanism that provides motion to the robot by converting energy, that is the electrical, hydraulic or pneumatic energy into mechanical movement. Final output of the robot arm is the movement one point to another point easily moves. It controls the speed, position and force of the robot joints to perform the task accurately. Functions of the drive system that produces required motion in robot joints, control speed, position and acceleration, transmits power through the mechanical elements. Here there is the three types of robot drive system: electric drive system, hydraulic drive system, pneumatic drive system. First of all, we have to see the electric drive system. The electric drive system is defined as the system which is used for controlling the speed, torque and direction of an electrical motor. Each electrical drive system is different from another electrical drive system. But there are some common features associated with all the electrical drive system. If we have to use the electrical drive system means we have some advantages, that is the high efficiency, precise control, clean and low maintenance. There is some disadvantages. Lower power compared to hydraulic system. If hydraulic system we have to use means more power. In electrical drive system we have to the low power. Then hydraulic drive. In hydraulic drive, a hydraulic drive system is the drive or transmission system that uses pressurized hydraulic fluid to drive hydraulic machinery. The hydraulic drive system working based on the Pascal law. The Pascal law is the pressure exerted anywhere in confined incompressible fluid is transmitted equally in all directions throughout the fluid such that the pressure ratio remains the same. Hydraulic drive can be designed to accurate either rotational or linear joints. Rotary van actuator can be utilized to provide rotary motion. Hydraulic pistons can be utilized to provide linear motion. Larger robots, there is a high speed and strength than hydraulic drive, high floor space needed. The leakage of oil is the one of the very big problem in the hydraulic drive system. Then pneumatic drive system. In pneumatic drive system used compressed air. The pneumatic drive system drives pneumatic cylinders or motors. In pneumatic drive system having the some advantages, simple and low cost, fast operation. Then disadvantages, low precision, limited power, that consumes limited power only. Then is the components of drive system. In drive system, components of drive system, there is a power source, actuator, transmission systems, control system, robot joints and links. The robot drive system selection based on the using the payload and the speed of the robot, how much accuracy is needed, what type of working environment, based on the cost wise we have to select the correct robot. The robot system is the heart of the robot which determines its performance, accuracy, speed, load and carrying capacity. Then next part is robot sensors. Robot sensors are devices that help a robot perceive its environment and monitor its own condition. They enable robots to detect objects, navigate, make decisions and perform tasks accurately. The robot sensor having different functions. First one is the environment sensing. Environment sensing means detecting surroundings like obstacles, objects, light, temperature and distance. Next is the navigation and path planning. The sensors help the robot move safely by identifying paths and avoiding collisions. Next is the object detection and recognition. Identify objects, shapes, colors or patterns for tasks like sorting and inspection. Next point is position and motion feedback. The robot sensor provide data about joint position, speed and direction for accurate movement. Next point is control and decision making. Send real-time data to the controller for automatic action and adjustments. Then safety monitoring. Detect humans or unexpected obstacles to prevent accidents. Force and touch detection. Enable robots to handle objects carefully by sensing pressure and contact. Environmental monitoring. Measure conditions like temperature, gas and humidity in industrial or hazardous areas. We have to use different types of sensor, position sensor, velocity sensor, vision sensor, temperature sensor. First of all is the position sensor. Position sensor is measure position, angle and linear displacement. That is a potentiometer, LVDT resolvers. Next is the velocity sensor. Velocity sensor, there is a measure linear or angular velocity. Example, there is a tachometer, Hall effect sensor. Next is the force sensor. Force sensor to measure force or torque applied. How much force and torque is applied in the robotic system. There is an example, strain gauge, load cells. Then is the vision sensor. Vision sensor capture image and extract information from the 3D vision systems, cameras, 3D vision systems. There is a proximity sensor, detect presence or nearby object without contact. That's an example, capacitance, ultrasonic optical sensor that we have to use. The different types of application in sensor, there is accurate motion control, obstacle detection, avoidance, object recognition and guidance, force control and safe information, safe interaction, process monitoring. Next part of the robot is robot actuator. Robot actuators are devices that convert electrical, hydraulic or pneumatic energy into mechanical motion to control or move different parts of robot. Different parts of the robot actuators. Robot actuator is a device that converts energy, there is a electrical or hydraulic or pneumatic energy into mechanical energy. Mechanical energy means that is a linear or rotary type or to produce movement in robot components or end effector. The robot actuator functions generate linear or rotary motion. Then robot actuator provide force or torque to move robot links and manipulate object. Then control position, velocity and acceleration of robot joints. Robot actuator hold or maintain position against external loads. Robot actuator convert electrical, pneumatic, hydraulic energy into mechanical output. Interact with the environment through the end effector. Different types of robotic actuators. There is an electrical actuator, hydraulic actuator, pneumatic actuator. Electrical actuator uses electrical energy to produce motion. Example, that is the DC motor, servo motor, stepper motor, feature high precision, easy control, widely used in robots. In hydraulic actuator, use pressurized fluid for motion. The hydraulic actuator features there is a very high force and power suitable for heavy duty robots. There is a hydraulic actuator applications, construction robot, heavy machinery. The pneumatic actuator uses compressed air to generate motion. Pneumatic actuator having fast response, simple design and low cost. Pneumatic actuators are used to pick and place robot, industrial automation. Then the function of pneumatic actuators. First one, produce motion. Actuator generate movement in robot either in straight line or around an axis. The motion enables different parts of the robot to function. Then drive robot joints. The power the joints of the robot, allowing the arm and body to move in required direction. This helps the robot perform tasks like lifting and positioning, control position and speed. Actuator ensure accurate control over how fast and how far a robot moves. This improves precision and efficiency in operation. Operate end effector. They control tools like grippers by opening, closing or rotating them. This allows the robot to handle and manipulate objects. Actuator converts energy. Actuator converts electrical, hydraulic or pneumatic energy into mechanical motion. This conversion is essential for performing physical works. Actuators having some advantages and disadvantages. First of all, see the advantages. High efficiency and performance, then accurate and controllable motion, suitable for various applications, improves automation and productivity. Actuator having some disadvantages can be expensive compared to hydraulic systems, requires more maintenance, there is a leakage of oil, some wear. Power consumption may be high complex control in some systems. Final part of the robot is the end effector. End effector, the end part of the robot hand. So that is the end effector. The end effector are devices attached to the end of the robot arm that interact directly with the workpiece or environment. Types of end effector. End effector, there are two types. One is the gripper, another one is the tool. Gripper is used to hold or pick and place the objects, but tools, that is a process the end effector, that is a perform specific task instead of gripping. The different types of gripper means there is a mechanical gripper, vacuum gripper, magnetic gripper. Grippers are applied in material handling or assembly operations. In end effector, there is another one type is the tool. Tools are used for end effector. There is a welding torches, spray painting and drilling or cutting tool application, manufacturing and processing task. Different types of grippers. There is a mechanical gripper, pneumatic gripper, electrical gripper, hydraulic gripper, vacuum gripper, magnetic gripper, adhesive gripper, needle gripper and special purpose grippers. In mechanical gripper, this is the most common type, uses actuators, high gripping force and reliable in mechanical gripper. Pneumatic gripper is operated by compressed air, requires the air supply. This is the fast and simple and environment suitable for pick and place operations. We have to use the pick and place operations. The next slide is the functions of end effector. Functions of end effector means there is a grasping and holding. There is a securely pick and hold objects, the manipulation of object, move, rotate or position items accurately. Performing operations, carry out tasks like welding, painting, cutting or assembly. Interacting with the environment, directly contact material or surface to complete task. Improving productivity, increase speed, accuracy and efficiency in industrial robots. Then applications of end effector. Applications of end effector, that is the material handling, pick and place operation in industries. Then assembly operation, fitting, fastening and component assembly, welding, arc welding and spot welding in automotive sectors, painting and coating, spray painting and surface finishing, machining process. We have to use in machining process, drilling, cutting, grinding, polishing process. Packaging industry, packing, palletizing the products. Then advantages of the end effector. There is a high precision. End effector are accurate handling and operation, increased productivity. There is a faster and continuous work. Flexibility, can be changed for different tasks. Next, reduced human effort. Reduced human effort means there is a minimize the manual labor work in the industries. Improved safety, there is a useful in hazardous environments. Disadvantages of end effector, there is a high cost. Initially, we have to spend the more cost to purchase the end effector. So initial setup and maintenance cost. Limited flexibility. Limited flexibility means there is a specific to certain task. Some tasks are we can do. Then complex design requires careful selection and programming. Then maintenance required. Each and every end effector required a maintenance. There is a wear and tear over time. Then dependency on power system. Failure can stop the entire process. Okay. Thank you.